right, so today we're going to, starting out chapter 3, again, because it's the beginning of the chapter, there's a ton of vocabulary we got to learn. We're going to talk about parallel, perpendicular, and skew, which hopefully you know 2 out of 3 of those. And then we're going to talk about some angles that are formed when we get some lines intersecting other lines. But let's start, first of all, with parallel, perpendicular, and skew. Parallel, the official definition is 2 coplanar lines that do not intersect. And by definition, remember, if you think back to chapter 1, parallel lines like this are always coplanar, because can't I put a plane through right here? Even if I put them like this, can't I draw a plane through them like this? Or like this, I could put a plane through. So parallel lines are always coplanar. And they are, they're always exact same distance apart, so they never intersect. All right, so Michael, give me two parallel lines on this picture. Yeah, EF and AB. Good. So EF, and make sure you give the right symbols, because a couple of you missed points on this even chapter 2 test because you had those symbols wrong. So make sure you're practicing writing the correct ones. The symbol, remember, for parallel is the 2 parallel lines like that. So line EF is parallel to line AB. Okay? Perpendicular lines are lines, and remember, anytime 2 lines cross, it's automatically on the same plane, so we don't even need to say that. But lines that intersect at 90-degree angles, okay? Those are perpendicular. I'm pretty sure you know that too. So give me a set of perpendicular lines there. H, D? Yeah. HD and F. Nope, those are parallel. Oh. HD and FB are parallel to each other, right? They don't cross. We're looking for 2 that cross at 90-degree angles. So let's keep HD. And what line crosses HD at 90-degree angles? Here's HD. What line crosses at 90-degree angles? F. FH, right? Because it's right here, right? Yeah. Crosses at the 90-degree angle right there. So FH and HD. And the symbol for perpendicular is an upside down capital T. So that says HD is perpendicular to FH. Okay? Now, skew lines are lines that are not on the same plane, so they're non-coplanar. They're not parallel, but they still don't intersect. And we've kind of talked about them before, but we didn't call them skew then. So we've got 2 lines on different planes. We've got this one going this way, this one going this way. Are they ever going to intersect? These 2? No, they'll never intersect. But are they parallel? No, they're not on the same plane. And if we put them on the same plane, would they be parallel? Would they? No. No, they cross. So they're not parallel, they're not on the same plane, but they don't intersect. So they have to be going different directions, because as soon as we put them in the same direction, like if I go like this, now all of a sudden they're parallel, and they'd be on the same plane. So they have to be going in different directions. All right, so give me a set of skew lines. James? EF and HD, perfect. And there isn't really a symbol for skew, we just have to list them. So line EF and line HD. Give me one more set of skew lines. Zach? EF and AB? No, those are parallel, right? Because EF's going this way and AB is going this way. When you pick skew lines, pick ones that aren't going the same direction. So EF and DH. Yeah. EF and, oh, we already got that one. EF and DH. Here's another one. CG and AB. Good. CG and AB. Perfect. Because they're not going in the same direction and they're not on the same plane. Good. Okay? Parallel planes are just like parallel lines. They don't intersect. They go forever in the same distance apart. How many points does it take to name a plane? 3. Good. So I need 2 planes that are parallel. Haley, what do you think? 2 planes. It takes 3 points to name a plane, so AEF. Okay, it's parallel to, I've used that parallel symbol. What's parallel to AEF? Yeah. Plane CGH. Good. Okay. All right, yes. There isn't one. There's no symbol for skew. Okay, so that's parallel, perpendicular, and skew. Let's take a second and just practice. Can you name parallel, perpendicular, and skew? Parallel? Yeah, the 2 vertical lines. Good. Good. Okay, we good with parallel, perpendicular, and skew? Feel like you got those? Yeah. Okay, so we are going to move on to some angles. Okay, so after taking all that time to talk about parallel, perpendicular, and skew, these lines are none of those things. They're not parallel, they're not perpendicular, and they're all on the same plane, so they're not skew. But it's really, we will continue to talk about these angles on June 7th. I mean, they are going to follow us the rest of the year. So it's so important that we understand what these are. All right, so first of all, you need to know what a transversal is. So a transversal is a line that intersects 2 other lines, okay? So I just see these 2 black lines here. I just drew 2 lines on the paper. I just drew 2 lines, okay? And then I cross a line through them. That line, this purple one here, is called a transversal, okay? And it intersects those 2 lines at 2 different points. So as an example, if I had a line that intersected both these lines but intersected it right there, that's not a transversal, okay? In a transversal, if I had the same 2 lines, they had to intersect those 2 lines at 2 different points. So this one is the transversal. This one is not. Okay? Does that make sense? Because that's a really kind of a good OGT question. They'll say, they'll give you pictures and say which one is the transversal. Well, it's not this one. This one. Okay? Yes. Okay. Okay. When you draw 2 lines and cut them with a transversal, and they use the word cut instead of intersect, I think because it's shorter. I don't know, you know how mathematicians hate to use big words. So whenever they talk about 2 lines cut by a transversal, that's what they're saying. You draw 2 lines, intersect it through both of them. Okay? It forms all these sets of angles. Okay? And the first set is called corresponding. So angles that are in the same position in the top line and the bottom line. So if you look at angle 2 here, it's to the right of the transversal and above the line, okay? So the corresponding angle to that would be to the right of the transversal above the line. So 2 and 6 are corresponding angles because they're the same spot in the upper line and the lower line. I should be jotting this down. Okay, so give me another set of corresponding lines. Kajana, give me another set of corresponding angles. We said 2 and 6 are corresponding. Give me another set. 1 and 8, no? Because it has to be the same side of the transversal, same side of the line. I'm sorry? Okay, well, if you knew the answer, you would have known it was wrong, right? So here's 1. It's to the left of the transversal and above the line. So which other angle is to the left of the transversal and above the line? Left of the transversal, above the line, down here. 5. Yeah, but you're just going on what she said. You didn't understand it, so I need you to understand. Okay? Give me one more set of corresponding. Abel? No. What are 5 and 6 and 1 and 2, by the way? What kind of angles are 5 and 6 and 1 and 2? They're adjacent, but more importantly, they're... What kind of angles are there from chapter 1? Yeah, they're a linear pair, aren't they? So don't forget about our old friends, just because we're meeting new friends. Don't forget about them. 1 and 2 are a linear pair, 5 and 6 are a linear pair. So we're really not talking about those right now. We're talking about corresponding. So let's look at angle 4. Which angle down here is below the line to the left of the transversal? Below, we're comparing angles from up here and down here. So to be corresponding to 4, it has to be below the line to the left of the transversal.
4 and 8.
Yeah, exactly. 8 is below the line to the left of the transversal. Okay? Now, the rest of them are exactly, they're nice because they describe exactly where they are. Alternate interior angles. Alternate just means on the opposite side of the transversal. So alternate interior angles means opposite sides of the transversal in the interior, between the two lines. Okay, so this purple section, between the two lines. All right, so alternate interior would be opposite sides and on the inside. So 4 and 6 would be alternate interior. Why not 1 and 3 again? Or 4 and 3, what are those? What kind of angles are 4 and 3? Linear pair. They're not, that's not alternate interior. 4 and 6 would be alternate interior. Okay? Alternate exterior, same thing. Opposite sides of the transversal, but on the outside, in this yellow area. So what would be alternate exterior with angle 1? 8. Oh, no. There's nothing there. 7. Because it has to be on the opposite side of the transversal and on the outside of the lines. So 1 and 7 are alternate exterior. 2 and 8 are alternate exterior. Okay? And same side interior is interior, so it's going to happen inside this purple area on the same side of the transversal. So somebody give me same side interior.
4 and 5.
Yeah, 4 and 5. Same side interior. Okay? All right, let's practice that. Get your cards out. We just drew just any two random lines, right? They're not parallel, they're not perpendicular, they're nothing, okay? But if we draw the two lines that the transversal intersects, we draw these two lines parallel, then all of a sudden, all those angle pairs we just learned have special powers. Okay? Corresponding angles, like 1 and 5, are congruent. Don't they look congruent? So when two parallel lines are cut by a transversal, corresponding angles are congruent. So jot that down. Corresponding angles congruent. Same thing with alternate interior, okay, like 4 and 6. Okay, those are congruent. And don't they look congruent? When two parallel lines are cut by a transversal, alternate interior angles are congruent, corresponding angles are congruent, and alternate exterior angles are congruent. So 1 and 7 are also congruent. When two parallel lines are cut by a transversal, alternate exterior angles are congruent. Okay? But it only happens when the two lines that are being cut by the transversal are parallel. If they're just two random lines, we can't say anything about them. They're not congruent, they're not supplementary, they're nothing. But when the lines are parallel, then we can say all this stuff. And same side interior, like 4 and 5, those are supplementary. Yeah, it might be for you because your sub left a while ago. Okay, and those are actually theorems and postulates. The corresponding angles postulate we don't have to prove, remember, because postulates are like duh, they're obviously true. Okay, so we're going to use that corresponding angles postulate to prove these other theorems. Okay, and the theorems, these are the summary of what the theorem said. Okay, the postulate says corresponding angles are congruent. The alternate interior angle theorem says alternate interior angles are congruent. And they all say they're, that brand of angles are congruent. All right, so let's prove one, because I know you're missing proofs. It's been almost